going to the next slide, which is malware. So now we had an overview of MITRE attack and what it means. Now we're going to get into malware, which is the core subject of the series. So when you ask anyone what is malware, chances are they will say malicious software, right? So that's correct, obviously, but there is more to it. So when it really comes down to it, there is generally no intrinsic difference between malware and benign software. Okay, they are both sequences of instructions which are executed by the CPU. And the proof that there is no intrinsic difference lies in the fact that there is not one anti-malware solution in the industry that has 0% false positive rate, but can detect all kinds of malware, aka 100% recall for those of you who are familiar with statistics. If it was obvious, which software is benign and which is malware, then it would be so easy to build an anti-malware solution. So maliciousness largely depends on three things: impact, consent, and context. Okay, so if someone executes ransomware on your system, okay, the impact is that your files are going to be unusable and it will disrupt your work. Now that is obvious, that's malware. Now consider another scenario. Okay, something is wrong with your system, so you call IT for support, and the person from IT says, "I'm going to remotely control your system using some software and troubleshoot the issue if you consent to it." Okay, and if you say yes, now this IT person now has consent to remotely interact with your system. Okay, so would you say the remote access software is malicious? If you replace this IT person with a threat actor and remove your consent, will you then say the remote control software is malicious? Probably. Right? So threat actors, they like to use benign software to perform malicious action. So for example, if you look at this particular blog from Huntress, so these guys used this TeamViewer software to access their targets' endpoints or systems. And TeamViewer is a legitimate product. Right? People use this for benign use cases and apparently also for malicious use cases. So this is a benign software, but it can be used for malicious action. So you cannot just look at TeamViewer and then say it is malware. So it depends on your consent context. Now there's an entire category of benign software. Okay, they are called lolbas, living off the land binaries and scripts. There's this website, lolbas-project.github.io, and they'll show all those binaries. It's usually Windows, but there's also Linux, if I remember. Must be there here somewhere. So it is basically, what it means is, how do you use benign software, or which benign software can be used to perform malicious actions? And they have an entire list of it. Right? It's a long list. So now, without knowing contextual information, right? Context as in how is the software being used or who is using it. So without knowing that sort of contextual information, detection becomes difficult. Okay, so if you suddenly write a lot of detection content for detecting TeamViewer, suddenly you will see lots of false positives, right? Because this particular application is also used for benign use cases. So now, because it depends on contextual information, now there are some categories of software which are again, you know, used by benign people as well as malicious people. So that context part of it becomes very important when you're trying to mitigate false positives. And in the industry, when you're trying to sell a particular anti-malware product to customers, they are going to be very, very concerned about what your false positive rate is, because their SOC analysts, they cannot, look at like 1,000 alerts every day, right? And if it turns out that all of those 1,000 alerts are false positives, then it's a massive waste of time and money at the same time. So basically, in summary, malware is malicious software given impact, consent, and contextual information. So many of you may have heard, a number of defensive solutions, right? You have antiviruses, you have VTRs, XDRs, sandboxes, firewalls, intrusion prevention systems. There's so many products. But despite all of these products, you still hear about threat actors successfully using malware in their kill chain, in their attacks. So the first reason for malware success is that anti-malware solutions are not like a silver bullet. Okay, they still need the intelligence or the detection content to identify and detect a file or its behavior as malicious. Now, this can be done through static signatures like Yara or ClamAV or Suricata or Snort rules, or there are behavioral signatures like looking for certain files in specific directories which are associated with known malware. Or it's done through machine learning models which are trained to detect malware. Or there are also some heuristics like like file entropy analysis, unusual spikes in CPU usage and things like that. But none of these methods by their own, on their own, is 100% foolproof. So usually anti-malware solutions will have a combination of all of these methods. So if your, for example, if your ML model encounters an unknown malware variant, okay, which is significantly different from the training data set of that particular model, then it may not detect that malware. Okay. Similarly, if there are no static or behavioral signatures for a malware, then it will not be detected. Now let's consider a scenario where there's an anti-malware solution that has all the intelligence in the world. Okay, it has all the detection content, but it consumes a lot of system resources. Okay, so organizations sometimes, because the anti-malware solution is consuming memory and then their users are complaining, what they will do is they will disable certain features of that anti-malware solution, like real-time threat protection on that product. And that and those kinds of misconfiguration will again create a gap in detection, and then you'll have a successful malware attack. Now, the second reason why threat actors use malware in general is because they can compile the malware executable once and then reuse it in all their attacks on different organizations. Right. So maybe they'll modify it slightly here and there so that its functionality remains the same, but the artifacts that it leaves behind on victim systems is slightly different. So for example, maybe a file that it writes to disk is named X in one attack, and in another attack it is named Y. Right. So they try to avoid being signaturized by anti-malware solution. Now the third reason is that malware can be delivered kind of anonymously to the target. Okay, you can deliver malware through phishing emails, by compromised websites, Trojanized software, and there are so many other ways as well. So threat actors don't need to be manually logged in to the target system to perform the attack. So malware gives threat actors sort of like a safety net by providing anonymity. So it's quite difficult to reliably attribute a given malware file through a threat actor. And in today's threat landscape, with malware as a service threat actors, it's become even more difficult. And for those of you who are not familiar with malware as a service, it basically is like software as a service, except they provide malware and not benign software. So where threat actors develop a malware and then sell it to whoever wants to use it. So not all threat actors need to have the expertise to write good malware. Right? They can just buy the malware. Now, let's leverage MITRE attack to understand more about malware, and we'll get into the core MITRE attack tactics and techniques. So the first tactic that we're going to look at is initial access. So at this point, what the threat actor is trying to do is they're trying to get into an organization. Within this tactic, I will answer the questions at the end. Um, so within this particular tactic, with the initial access, there are three techniques that we're going to look at. We're going to be looking at phishing. We are going to be looking at exploiting public-facing applications, and then we'll look at compromising software supply chain. So basically, we look at malware which has implemented these techniques or which was used to achieve these techniques. Let me see if I can share the other window. And in the meantime, I'll just answer the question. File names are changed, yet it is detection based on hash value. It is not based, the detection is not based on hash value. That is, detection based on hash values is like the simplest thing that you can do, and it is usually not used a lot. Because what happens is, let's say you have a malware executable, and then you calculate its hash, and then you put it in your block list. So tomorrow, if let's say the threat actor appends, one null byte at the end of the file, the hash will change. Okay. So now it's no longer blocked. Its functionality has not changed. Really, nothing has changed in the malware except that last null byte. and then you'll still get compromised because you were relying on hash-based detection. File names detections and file directories, file names, those are those are part of behavioral signatures. For example, when you take an executable and put it in a sandbox, so you will see all the behavioral report that is generated, right? So whenever this executable was executed, then it wrote to this file, it wrote to this directory, it did this network communication, etc. So you write signatures based on that behavior. So let's say you have again these two malware executables. You have one, the first one, the original, and then you have the second one which has a null byte appended to it. Now the hash has changed, but its behavior still remains the same, right? It's still going to write to that same file name, still going to write to that same directory. So when you have a behavioral signature, you can still detect both of these malware. It's not like hash-based detection. That's different. So let me try and share the other. Can you guys see? Swati, can you see the VM, the virtual machine?
Yeah, it is visible.
Awesome. Okay, we have pause. Let me know if it suddenly goes out of focus. Discord has some
Sure.
weird styles. Right. Okay, so we'll start off with the phishing technique first. Let me just take out that sample. You're still able to see the screen, right, Swati?
Yeah, it is working. I'll let you know if there is an issue. Yeah.
Okay, so the first one that we're going to be looking at is phishing. Okay, so this is basically an email that had come to a certain person, the target. So you will see at the start is the email header. There are a bunch of fields here, but what's important to know here is that some of these fields, they can be spoofed. Okay, so this one looks like it coming from First Bank. So when you see it in your email, it will show up as mobile app.firstbank. So it looks legit, right? But then if you go back and see where it actually came from, you will see it's coming from some random source. So instead of reading this, which is a little bit, I guess, not particularly readable because there's so much information. So what you can do is you can take that email header and go to MX Toolbox. So you just come and paste it here. You say analyze header. Okay, so you get all this information. Now what's important for us is to where this email came from originally. You see this hop one. This hop one basically means when the threat actor sent the email, what was the first email server that email went to? In this case, it was the Zigo dot whatever. So if you just take this now, because this looks weird, and again, what looks weird is kind of relative, kind of depends on your experience. Some of you may not find this weird, some of you will find that weird, but that ability to recognize what's weird and what's not comes with experience. So when you search it on Google, right, that particular domain, there's this one hit, and turns out this is 404 keylogger malware. It's related to that one. So if you go back now to the original email, this one, and you'll see at the bottom there is some attachment here. You'll see there's some file that has been attached to that email. So now what you want to do is you want to analyze what this is. Okay? And to extract that attachment from the email, there is a tool called UUDWin. Where it is. UUDWin. So this tool is basically used to extract email attachments. When you have just the email file called a EML file, so you can just take that EML file and then put it into this tool UUDVIN, and you can extract whatever attachments are there or whatever files can be extracted from that particular email file. What we are interested is in this RAR5 file because this is a compressed file, so it automatically becomes more sort of interesting. So now if you unzip it, you'll see there's an exe file sitting inside it. So the phishing email basically had a zip file, and within that zip file there was an exe file. So chances are whatever that email content was, where's that email? Whatever this is. So in most cases, what will happen is, here it is. Sorry. Whatever that text is, usually it will be some kind of like a social engineering tactic to try and make the user open this exe file. So that will be whatever's there in the text. So it'll be some kind of urgent thing, right? It'll be like, your invoice payment has been declined. So open this file, and then that will fix the situation or whatever. So when you come to the CXE file and you come to this payload, as it's called, you can just hash it, SHA-256, MD5, whatever is available. You can just go to Virus Total. There's a website called Virus Total. This is like basically a large repository of malware files and benign files, and it's pretty much a good indicator if something is malicious or not. Again, it's not foolproof. Just because Virus Total says zero detections doesn't mean it is not malware. Maybe none of the engines detected it. So that is one aspect of Virus Total that you need to keep in mind. Not all engines will name a particular detection as that particular malware, and sometimes some malware are named differently by different organization. So Snake Keylogger is one name for this malware, but if you go to its entry, so there's another called Malpedia. So this is again like a knowledge base of malware specifically. So we'll see it's also known as 404 Keylogger, the same malware, right? It has different names. Naming is definitely a drawback of the cybersecurity industry. So this is how phishing technique was implemented in this case. Okay, it is a particular procedure. There are different ways to do phishing. Maybe you have a phishing email which has maybe a different file attached to it. Maybe it has an HTML file attached to it or JavaScript file attached to it. Maybe it's a directly zip file, or maybe it's directly a different file. It's called an LNK file. It became quite popular at some point. LNK file, there's ISO files, there's doc files. There are so many other file types that you can attach to your email to achieve your particular technique. Now the next one, okay, now, the screens again. So the next one that we are going to be looking at, yeah, the next one that we are going to be looking at, the next technique is exploit public facing application. So if we go to the particular technique number T1190, so this particular page of MITRE attack will give you sort of like a description of what this technique means. So for phishing, it was quite obvious, but for public facing applications, they have a nice little description. So in this one, we have a malware category called exploit kits. And the malware family is called RIG. So RIG is the malware family name. Exploit kit is the malware class or malware category. Now you can have, open up better. Uh, Come on. Attention. Give me 1 second. I need to find the file where.
Nikhil, your screen sharing stopped. Hey Nikhil, your screen sharing stopped. So you
It
can.
okay. Give me a second. Oh, can you see it?
Yeah, now it's working.
Okay, awesome. Okay, I'll just go back to the original PDF. Hopefully, I don't have to find too much. Okay, so right. So as I was saying, so this is for a malware category called exploit kit, and the malware family is rig. Now you can have multiple malware families within one malware category. So rig is just one malware family. There can be others as well. Now the exploit kits are usually used to try and exploit vulnerabilities so that it can later download the next malware, okay, or it's called the next stage. And then the next malware is downloaded and executed. In this case, the rig exploit kit, it exploits two CVs. So one is CV 2019-0752 and the other one is 2018-8174. And now this is an unpatched Internet Explorer browsers. Now you may think Internet Explorer is gone, right? So everyone uses Edge or Chrome or Firefox or whatever. But there are many organizations which are, which have difficulty upgrading their systems. So they're still running on Windows 7 or Windows XP or some old system where there is still unpatched Internet Explorers. So if the threat actor finds them, and the threat actor will specifically try to find them, then they might get compromised because of this. Now the exploitation chain, it starts with a malicious ad being delivered from a legitimate website. Okay. Now there's an entire attack type called malvertising, which basically means malicious advertising. Okay. So if you look into the online ad ecosystem and how malvertising is performed, it's pretty sophisticated, it's pretty complex, the ad ecosystem. So anyway, so once the malicious ad reaches the victim browser, JavaScript is executed and it redirects the victim through a bunch of intermediary pages and finally to the landing page where the rig exploit kit code reaches the victim browser where it performs two exploits. So you'll see all of these 302s. So these are all redirects. Now, there are a few reasons why threat actors sort of perform many redirects before they actually reach the landing page. Okay. So the first reason is to hide the source from automation or threat research. So the second is to perform some kind of profiling on the victim before they actually show you the landing page. Okay, so for example, this particular CV is only for unpatched Internet Explorer browsers, right? So let's say you visit with Chrome. So what may happen is, one of these intermediary pages, they will check which browser you are actually visiting this page from. If it is Google Chrome, then it will not show you this landing page. It will show you some other normal website. It will show you google.com or something. But if it is unpatched Internet Explorer, then it will show you the landing page. Okay, so it is more targeted towards your your targets. Now, the next few pages of this report, they explain, obfuscation, how the JavaScript obfuscation is. Like, for example, you'll see these different kind of things, different kind of obfuscation. Now, I won't get into this because it's not a malware analysis course. But if you're interested, please reach out to Swati. Um, so now it's, some things that you can see in this obfuscation is there's all these string obfuscations. You'll see all these random variable names. These ones actually you come across quite regularly when you deal with JavaScript malware. JavaScript can, to be honest, can be obfuscated to hell. So it is quite frustrating when you deal with, you know, very obfuscated JavaScript malware. It's a headache. But anyway, so this particular exploit, uh, this was inspired through a proof of concept exploit, which is there online. Right, so you'll see threat researchers post their POCs online, and usually with every GitHub repository that's present for a particular POC, it will say this is not to be used for malicious purposes, only for education purposes. But we all know it is going to be used for malicious purposes, right? So this particular exploit is also inspired from a public POC, and you'll see some VB script here. And VB script is supported by Internet Explorers, but not others like Firefox or Chrome. Now, if you scroll down below, now you'll see here that there is a PowerShell command being executed. You'll see this PowerShell, see the start process. Now, when you come and see here, there's also a C2 IP address. There is also a particular file name which is 3.tmp. And again, this is a hard-coded file name. So it's not like a randomly generated file name. So this becomes something that you can write a signature off of. So if you come across this particular file on your Windows system, maybe you can alert the user that something is wrong, and we think that this is rig exploit kit or whatever. Now with the this particular C2 IP address, this is unfortunately an IP address. It's not a domain. Okay. So when you write detection, you generally don't write it for IP addresses because multiple domains can resolve to the same IP address. So there's something called shared public hosting. So multiple websites will share a single server. Okay, so their IP address will remain the same. So in case you go and block this IP address, if there is some other benign website running on that IP address, it will also get blocked. So ideally you don't write detection on IP addresses, just on domain. Now what the last part of this is I think there was some RC4 somewhere here that I remember. Now for those of you who are interested in doing malware analysis, if you see this kind of a loop anywhere, especially this 256 number, two loops, 256, that itself is a very good indicator that RC4 encryption or decryption is going on somewhere. But yeah, that's only for people who are interested in going much lower than reading source code. If you when you go and look at assembly, then these kind of tips will be much useful for you to understand what's going on faster. Now the decrypted data, whatever was decrypted with RC4, it's saved with a random name. It's a DLL or EXE, and then it gets executed, whatever the DLL or EXE is. And the nice and the unfortunate part for a blue teamer, but nice for a red teamer, is that this DLL or EXE, it's named randomly. The file name is random. So before we saw that TMP file, this was not random. So you can detect this, but detecting this might be a little difficult. Now there might be certain patterns that you might notice, like the random name may be a fixed length of characters. Maybe it is just 5 characters all the time, and it is just lowercase or it is just uppercase. Then you can try building a detection on that also, but it's a little bit more difficult to avoid false positive in those cases just because it's a random name. So yeah, so that's the sort of the public facing application techniques malware. Unfortunately, that I couldn't get this malware to actually reverse it live, but at least we have the report. And for those of you who are trying to learn malware analysis, the best way to learn malware analysis is you have the sample and then you also have a report of that sample, so technical report. So you can just follow through the technical report and see if you can follow along in the malware. And for one of the malware, we are going to be doing exactly that, which is for the compromised software supply chain. We're going to be looking at that malware. Let's go back to my VM.